Right. So today we'll be speaking about the monostable multivibrator and the astable multivibrator numericals. So 9.11 in the circuit of 9.16a, C is equal to 0.1 microfarad and the output pulse width is 1 millisecond. Determine the value of RA. So C is given, output pulse width is given, and the value of RA is to be found in the figure 9.16a. So let us see the 9.16a. So this is 9.16a and B. So these are the figures, and this is the circuit for the stable multivibrator monostable multivibrator. So it's a monostable multivibrator. You can see input and output waveform. Monostable will have an input and an output. So where the input is given is here. We are giving the input here, and we are taking the output at this point. Okay, at this point we are going to pin number 3. Okay, here is the input. Here is the input, which is corresponding to pin number 2. Okay, so for this input over here, trigger input like this, the output waveform will be this, where the delay time is this TP. TP is the delay time or pulse width or pulse time or whatever you call it, right? So this is the charging of the capacitor, which is there, or at the proper place. You can see where that capacitor is here across 7 and the ground. Between the 7 and the ground, you have the capacitor, and charging of the capacitor is taken care. I'm not going into the details of the operation and all that. Okay, let us not bother. We are just bother about the internals, and in that, what are the numericals? Okay, so let us see that. So for this, let us see what is the formula. So this is the formula. TP is equal to 1.1 RAC. The timing during which the output remains high is TP is equal to 1.1 RAC. So we are given with the value of the output pulse width, which is 1 millisecond, that is TP. C is also given 0.11, so we need to find RA. That's all. So very simple. TP is given 1 millisecond, 1.1. C is given 0.01 microfarad. Is it 0.01 or 0.1? 0.1 microfarad. You need to find the value of RA. That's all. Okay. So no big deal. So next we'll go for 9.12. In the monostable multivibrator of 9.16a, again same figure. C is equal to 0.01 microfarad and RA is equal to 2.7 kilo ohms. So we are given C and RA. Calculate the duration of the output pulse width TP. So formula is just the same. Now we need to find TP given RA and C. Okay, given RA and C. So very simple job. 9.13. The monostable multivibrator of 9.16a is to be used as a divide by 3 network. The frequency of the input trigger is 12 kilohertz. If the value of C is 0.05 microfarad, what should be the value of RA? So let us see that frequency divider. Yes, this is frequency divider. So here it is mentioned that to use the monostable multivibrator as a divide by 2 circuit, the timing interval TP must be slightly larger than the time period T of the trigger input signal as shown in the figure. By the same concept, to use the monostable multivibrator as a divide by 3 circuit, TP must be slightly larger than twice the period, and so on. So for divide by 2, it should be slightly larger than T. For divide by 3, TP should be slightly larger than twice the period. For divide by 4, the TP should be slightly larger than thrice the input period of the input trigger signal and so on. Okay. So now what is asked is divided by 3. Divided by 3 means slightly larger. So if you see this example for divided by 2, he has taken TP as slightly larger than T, that is 1.2 times of T. 1.2 times of T. Now for divided by 3, TP should be slightly larger than 2T. 2T, right? So that means 1 point TP will choose it as 1.2 into 2 into T. So that is 2.4 T. TP is 2.4 T. And again, TP is 1.1 RA and multiplied by C. So for this problem, right? For this problem, which is divided by 3 network, we have 2.4 T. 2.4 T, and T is 1 by 12 kilohertz. Okay, frequency of input trigger is 12 kilohertz. So T will be 1 by F. 1 by F is 1 by 12 kilohertz. So 2.4 divided by 12 is equal to 1.1 into RA into 0.05 microfarad. So only one unknown RA. Only one unknown RA. Similarly, you need to repeat the same problem with a frequency of 4 kilohertz. That is 2.4 divided by 4 is equal to 1.1 into RA into 0.05 into 10 to the power of minus 6. Micro means 10 to the power of minus 6. Okay, so thus we can just calculate for the 9.14. Okay. So any doubt you have, you can just tell. So free running frequency just means F naught. Okay, F naught. F naught is equal to 1 by T is equal to 1.45 RA plus 2 RB into C. So anything? Any doubt? No doubt. Okay. So this finishes the the whatever problems were there.